This conference will now be recorded.
Hi all, can you hear me?
Yeah,
So let's have a small session today since you people joined. I understand it's too early for the most of the people, so they might skip today's morning class and we'll ensure that the other people are going to join from tomorrow. So let me share my screen, what we are going to be cover and the basic theoretical concept for statistics we'll try to cover today. So when I say basic statistics, it's not meaning that the statistics what we are going to cover either today or coming 1 week is good enough for data science. We split the data statistics into two parts. One is a basic statistics, and the second one is advanced statistics. Once we complete the of basic concept of statistics, then we will go to Python. Whatever we learn in statistics, the same thing we'll try to replicate in Python code with a similar data set, so that you'll come to know are you getting the similar answers what are you learned using paper and pen. When I say paper and pen, nowadays no one is using, so we'll go with Excel. We'll try to see the outcome. We'll try to understand based on the outcome what kind of interpretation you have to take it. We'll try to understand. After 3 days or 5 days or 6 days, we'll switch into Python and we'll try to learn the basic Python. So whatever in statistics, you maybe five concepts or six concepts what you're learning, the same data set, same thing you're going to use it in Python, and we'll try to see the same results. So that way, hand in hand, we are going to learn statistics followed by Python. When I say basic statistics, we are going to learn into five different topics. The first one is try to understand the data types. In a general world, we have two things. One is a test, other one is the numbers. Numbers means 1 to 9 and 0, and text means anything including emojis we consider. But the same data, whatever you are utilizing on day-to-day life for conversation, when you try to convert into statistics, we have four different types. The first one is called continuous data. When I say continuous, I'm just talking about the first one. Hope you can see my screen. So continuous numerical data. That means when you have some data, if the data can contain the decimal points, we call it continuous numerical data. Let me tell you, I'm just sharing my Excel sheet now. Number of laptops. Number of laptops on laptop price. Can you see my screen?
Yeah, we can see.
Okay, great. So number of laptops, the second person has four, and the price is number. Now we have two numerical data. Number of laptops is 1 and 4. That is a numerical data. Laptop price also a numerical data, nothing but numbers. But when you see the question, the heading, number of laptops I can maintain without a decimal point. I cannot say that I have 1.5 laptops, 1.7 laptops. I can say either one laptop or two laptops. That is called discrete numerical data. When your question, if you ask any question to any number and the answer cannot maintain any decimal point, we call it a discrete numerical data. If your question, once you ask, and the answer is a number, and a number can contain a decimal point, then we call it a continuous numerical data. So, though I mentioned 40,000, it's nothing but 40,000.00 or 40,000.01. So if I have an option to maintain a decimal point, we call it as a continuous numerical data. Is it clear? Anyone have any questions on this? difference between continuous numerical data and discrete numerical data. So let me ask you how many brothers you have. You may answer 0, 1, 2, and so on. I cannot say I have 0.5 brother, 1.5 brother, 2.5 brother, right? Either I have to say I have a brother or I don't have a brother. If I don't have an option to maintain a decimal point, that is called a discrete numerical data. If I say what is the height of your brother, I say 5.5. I have an option to maintain a decimal point. Though I mentioned 5.0 or a 5, I have an option to maintain a decimal point. When I have an option to maintain a decimal point, that is called a continuous numerical data. Continuous. Do people understand the difference between continuous and discrete? Anyone have any questions? Team, is it clear? Continuous and discrete. Preeti, Sai, Sandeep, Srikanth.
Yeah, I understand. Thank you.
Yeah. So, Amar, why should I learn these two differentiations? Is it mandatory? Yes. When you are going to statistics, from basics to a moderate statistics, you need to understand the clear difference between continuous and discrete. Accordingly, the formulas will change. Since the formulas are going to change, the basic statistics formulas, the outcome is going to be changed. So that is the reason we need to differentiate both. A simple terminology, generic terminology. If you remember, we used to play a probabilities. What is the probability in the next card or the what to say the cards? 52 cards. What is the probability you are going to get a king or queen? So since you have 52 cards, you cannot maintain a decimal point. The probability is changing. If I ask you another question, what is the lifespan of a fly or a mosquito? You can say ideally it can be 3 to 5 days. So the range you are provided. It can live 3 days, or it can live 3 days, 1 hour, 3 days, 2 hour, or 4 days, 4 days, 1 hour, so on. You are giving a range. Since you are giving two different directions for two different activities, the formulas are going to be changed and the outcome is going to be changed. So for continuous, you come up with a range. For discrete, you are coming with some random number. That is the reason we need to differentiate when there is a question. What is these questions? These are nothing but a data which you collect from your different sources, maybe from the server, from the marketing research, anywhere. So once you get the data, if it's a numbers, try to differentiate which is a numerical, a continuous numerical. The second one is which is going to be discrete numerical data. If you differentiate, you're good. If you have an option to maintain a decimal point, it's a continuous. If you don't have an option to maintain a decimal point, that's called discrete. Now, nominal and ordinal. What do you mean by nominal data and ordinal data? These are both are test informations. These are called test information. When you have an option to maintain all the tests in a sequential order and predict what kind of test it can be with the help of some numbers, then we call it ordinal data. If you are using test as a test, I don't have any problem. I can say that Amar is a data scientist and is giving some trainings. I'm okay. That is a test, some sentences. If I'm trying to analyze some test, that comes under test mining, alias natural language processing. Nowadays, what you're seeing, Alexa or a Siri, those things comes under that category. But some scenarios, I need to do some aggregations. Nothing but how many times the word is repeated. How many people are comfortable with IBM company? How many people are hating some X company? If you want to aggregate, do some basic statistics on test, then I need to convert the actual test into ordinal or a nominal data. How can I do that? In the sense, say for example, I'm asking you, how is a Kalki movie? You can say very bad, bad, um, average, good, or very good, or if you want to give one more like a fabulous, it's up to you. So if you see here, all these are different tests you may receive with the help of survey or the feedback which you receive from Book My Show or something. Now, I can give a rating for aggregation purpose because my Python code cannot understand the test as is. So I'm going to give a label like 1, 2, 3, 4, and 5. Or I can give label like 5, 4, 3, 2, 1. It's just a label for doing some mathematical calculation or statistical calculation. Nothing more than that. So once you give the labels like sequential order, either from top to bottom or bottom to top, if I ask you a question, how is Kalki movie? You might answer a 5 out of 5. When I say 5 out of 5, that means I can assume, I can predict the test is going to be a very good or fabulous. If can I convert very good into average and average into 5? Is it possible for me? Can I give 3 rating to very good and 5 rating to average?
No.
Is it possible? No, because you cannot assign the labels as per your wish. You have to go either ascending order or a descending order. If you want, if that is the condition, that is called ordinal categorical data. Categorical means test. Now, there is another example. You might receive some calls from, in case if you are studying some college or if you are trying to attend for some interviews, the HR called you and asked you, what is uh, what is the rating in your X skill, maybe data science skill, or your English proficiency? Can you rate yourself out of 5 or out of 10? So out of 5 means there, if you mention this is the where 5 is the highest or where 5 is the lowest, they may tell you like that. When they tell, you can predict, okay, 5 is the highest means that is going to be very good. Just one step below, that is going to be good, and 3 is going to be okay, maybe meeting the expectations, something like that. They can give the rating. So if you're going coming to the performance points of view or skill point of view or any other point of view, if they're maintaining a sequential order and they're giving some aggregation, some labeling like 1, 2, 3, 4, 5, some numbers for doing some aggregations or statistical calculation, basic statistical calculation, then you have to convert your test into categoricals. So when you convert into categorical, again you have two differentiation. One is a nominal, other one is a ordinal. And ordinal means it's going to be a sequential. Nominal means no sequence. In ordinal, if I hide the actual test by seeing the labels, I can predict 5 is the highest and 1 is the lowest, 3 is the average. But where if I coming to nominal, 1, 2, and 3, male, female, and by gender. So these are called gender information. The previous one may be rating, and now it's a gender information. I'm just giving how many male people uh, participated in my survey, how many female people participated in my survey, how many bigender people participated in my survey. Is it a mandate I need to give 1 to male, 2 for female, and 3 for bigender? Means no. I can give 1 here, I can give 3 here, I can give 2 here. I can give any label to any gender. There is no criteria to follow. The sequential order, no need to follow. You can give any label to any gender. If this is the situation, we call it as a nominal categorical data. If people understand what is the difference between nominal and ordinal, any questions? Let me know if I'm going fast. I'll try to reduce my speed. And apart from that, we have two more data types. One is a ratio and other one is interval. So with an examples, we'll try to understand those concepts going forward. And once you complete the topic 1, we'll go for topic 2, which is going to be a basic statistics. Whatever we covered so far is just to identify the data. Those are not a basic statistics. Those are to identify what data type is going to be what. Now, once you identify the data type, then you can apply basic statistics. That is going to be first, second, third, and fourth moment of business decision. Like identify the average, identify the median, identify your variance, identify your standard deviation. And once you get a large data set, how to identify there is a missing values. how to identify there is an extreme values. When you say extreme, in a statistical terminology, we call it as outliers. For example, every day I was spending every day I was spending 100 rupees as a pocket money from your father, 110 rupees, 90 rupees, and so on. One day is your birthday. You took all your friends and you celebrated at a hotel. Now the price amount is 1000 rupees. Now, if I take an average that is coming somewhere around 280 rupees. Average coming as 280 rupees. Are you expecting every day you're spending somewhere around 250, 280? No, right? Practically you're spending 100 or 190 or 110 rupees from the last 1 year. But because of birthday, you spent 1000 rupees with your friends. Are you, this 1000 rupees spending is repeating for another 364 days? Team, just imagine another 300 days are going to spend 1000 rupees per day. No, right? You are going to continue to spend 100 rupees or 90 rupees or 110 rupees, right? Somewhere around 100 rupees you are spending. Are you agreeing with that? Team, are you getting my point? Is anyone not getting the point? Sai, Sandeep, Srikanth, Preeti.
Can you repeat it again, sir?
Okay. Now assume that your daily spend is 100 every day. Daily you are spending 100 rupees or 90 rupees or 110 rupees. On an average, you are spending 100 rupees. Okay. One day is your birthday, someday. So that day you spend somewhere around 1000 rupees. So since one day you spend 1000 rupees, if I take an average, how much is coming? It's coming somewhere around 230 rupees per day you're spending. Can I say like that? So let me
Correct.
take an average. But practically, are you spending 200 rupees per day?
Yeah, if I spend $1,000, yes. Yeah. Yeah.
If you spend $1000, on an average, coming as 280. But practically per day, how much you're spending?
Uh, Around $100.
Around 100 rupees or 90 or 110 rupees. So how much differentiation you have it? Huge amount, right? Where is 100? Where is 280?
Yeah,
Because
correct.
one day it was a function or a treat. Because of that, we spent. But practically, is it going to be repeated every day?
No.
No. For a small number only, we are getting confused. Just imagine broader level. Like when you are extracting the data, those are going to be in 1 GB, 2 GB, or maybe 10 GB or 100 GB. So when you extract that much huge amount of data, is it practically possible to analyze whether there is a huge difference or not? We don't know. So what we do, we are going to apply this first, second, third, and fourth moment. Starts from finding the average amount in our example. What is the deviation you have on amount to amount from the average? And we are trying to identify is there any extreme values like 1000. So since this has happened because of our wish, the 1000 rupees is happened because of our wish, but not practical is going to be continue every day. So try to find out the extreme values, either lower side or upper side. Lower side, upper side. Try to find out the extreme values. We call as the outliers in statistics. Try to identify, then remove that. Once I remove, you can see the average is coming as 100. Practically, the average value now is very close to your daily expenditure. Can I say like that?
Yes.
So these are the techniques we have to learn during our topic 2. Once you complete those things, then we are going to cover probabilities. So once you complete your basic statistics, once you clean your data pre-processing activities, once you identify the extreme values, then come to your random variables and probabilities and probability distribution. Amar, I am here to learn data science. Why should I learn probabilities? Even probability is a bridge between your basic statistics and advanced statistics. These are nothing but inferential statistics. So once you complete your probabilities and hypothesis, then you're going to learn your simple linear regression. Amar, why should I learn hypothesis? Hypothesis is nothing but taking small data and estimating about either population or large data. For example, during our COVID situation, we have corona vaccination. Do you think that while developing the vaccination, they applied on entire population, or they took only 100 people or 200 people, and they observed whether the vaccination is working fine or not? When they used to develop the vaccination, either the first version or second version, third boosting or boosting vaccination, whatever it may be, so they developed some vaccination, right? And they mentioned out of 100 people, 99 people, the corona will go off, and might be a 1% chance the person may get side effects. They to give that kind of statements. How they decided that? In a sense, they while developing that one, while testing on a small population, maybe 100 people or 50 people or 1,000 people, I will tell you how to choose this number, sample number, 100 or 1,000 or 2,000 numbers, how to choose, we'll discuss during topic 4. So they took the sample, they identified the sample, and they injected the vaccination. Once they injected the vaccination, out of 1,000 people, how many people got cured? How many people not cured? So basis of that, they estimated about population. You got my point? When I say population, it can be India population, it can be world population, it can be universe population, depending on the topic. If you're talking only about India, India population. If you talk about world, it's a world population. So by taking a small data, how you can estimate about your population data, how much you can stand on your results. Are you sure? You might took 100 people from the soldiers. Soldiers are more effective, and they are, you can say, more willpower, more stamina they have it. So if any kind of disease they come, they can cure. What if I take old age people? What if I take children? So you have to think in all the aspects, and you have to stand on your results. If I want to stand on my results, I need to know statistics, how that particular sample results are influencing my population data. So that is called inferential statistics. We'll discuss in topic 4. Once you complete topic 1, 2, 3, and 4 in a month time or 1.5 month time, then we'll jump into simple linear regression. This is the first method you're going to learn in your data science machine learning models. Why purposefully we maintain in this agenda means most of your questions comes up from, when you say machine learning models, most of the questions comes from your simple linear regression. Reason behind, there are certain assumptions it has to follow. It's not meaning that other models should not follow. Once you understand these assumptions in simple linear regressions, then 50% of your course is completed. And once you are good at simple linear regression, you are in a position to understand all other concepts in a month time. So there are many machine learning models. Even you can develop your own model also, which others may not. So when you are developing a new models, these are the basic foundation, you can say, to enter into machine learning models. You got my point? Though this is a machine learning model, simple linear regression is first model in machine learning. But before entering to other models, you have to learn this one perfectly. That is the reason it comes under basic statistics. Any questions from anyone? Team, any questions?
No, sir, I'm good.
Okay, great. So with this concept, basic understanding, I'm just dropping, and tomorrow we'll enter into statistics. We start sharp at 6 o'clock. First 5 minutes, I'll go with question and answers, considering the it's a too early in India. So some of the few people are joining from India. So considering they're going to be joined 5 minutes grace period, like something like that. The first 5 minutes I'll go for question and answers. The question and answers are related to your topics, not related to your fees or some etc. Just related to your data science related concepts. Once the 5 minutes or 10 minutes based on the question and answers, once that is completed, we will enter into the topics. So that with this method, the people who are going to join late, they will not miss the topic if they join by 5, 6, 5 or something. If they join by 6, even their persons can listen the question answers which are coming from other people. So consider first 5 minutes is going to be grace time for question answers. Any other questions from anyone? If not, from tomorrow we are going to enter statistics.
Thank you,
And
sir.
from tomorrow we are start. Once by end of the day, you should be in a position to analyze what kind of data you have to consider for your case study. So those things we'll try to see. When I say case study, not the real case study, practically how you are going to analyze, how to get your data, you need to understand. From tomorrow onwards, we'll start thinking in analytics point of view. Thank you.